So in this video, let's talk about the Prim's eager algorithm trace. So Prim's algorithm, as we know, start to build the MST or minimum spanning tree, starting from an initial vertex. So once let's pick the initial vertex to be A. It doesn't matter which one you pick, as long as you follow the algorithm. But let's start with A. And from A, we're going to pick all the edges that are going out of A, incidents to A. So we have, note now, edges going to B would be AB with a weight of 3. And going to C would be AC with a weight of 6. And going to D would be AD with a weight of 2. Now, at this point, what we're going to do is, in Prim's algorithm, we're going to put this into a priority queue. So one of the things you want to notice is that we have a min priority queue of vertices, so it doesn't use as much space as the lazy algorithm or the Kruskal's algorithm. So let's pick this vertex here as part of the MST. So now we have two vertices in the MST. And then what I'm going to do is I'm going to draw the cut now. So MST theorem says that the next vertex you want to add is to look at all the edges that are going out of the cut to the other side. So we're going to mark this C, which is CD. So that has a better connection to getting to C than the previous one we have. So we're going to change this to CD with the weight adjusted to 3. So that's an example of a decrease key in implementing Prim's algorithm. And then let's go take this one here. So that edge would relax E, not relax E, but change the distance so that we can add the ED to the minimum spanning tree with a weight of 8. And if you look at this one here, that would add DG. So DG, it will connect G to the minimum spanning tree with a weight of 7. So that's all I have. So we have AB considered, all these considered. And now what we need to do is to pick the minimum such thing from the list. So let's just pick, in this case, let's pick AB to be the next edge added to the minimum spanning tree. So I'm going to circle the edges that I added to the minimum spanning tree. These are the weights of those edges. So if you add B to the minimum spanning tree, you have this now. So these are the edges. And here's the cut. So we draw the cut. Now from here, now you can see that BC would give you an edge weight. So for example, C, I have CD, but I can replace that with BC. So let's replace that with BC with a weight of 1. And then what else we can do? So we can see the BE can be added. Yes, we can add BE with the weight of 6. That's smaller than what we have now. And then we can, so it's already considered here. It's already, all of them are considered. Okay. So that's where we are. And the next thing we are going to choose is the smallest of these things, which is going to be C and 1. And it's going to give me the BC as the edge that's add to the MST. All right. Now, if you look at the cut, so connect this one here. So you look at the cut contains these 4 vertices now. So at this point, I can consider an extra edge here, which is CE. So I have a BE with a weight of 6. So I can replace this with CE now with a weight of 4. All right, and that's all I can do so far. And I'm going to pick the next smallest thing from this priority queue. So that would be this and that and this. So I'm going to add E to the MST CE to the MST, and that's where MST is. Now let's draw the new cut, which would be this. So that gives us two edges to consider. So G, I can use EG with 3. So yes, I will replace this by EG with 3. And now, let's see, so EG with 3, and then I can say EF with 2. Yep, so I can put EF with 2 here. And that's all I need to consider. Now I can pick the minimum thing from the priority queue. So that would be this edge and this vertex. So it's F here and the vertex EF. And I'm going to color that right. And finally, I have EG. So there's a cut now. So if you take the cut, here's the cut. The only thing I haven't considered is this edge here, FG. So FG would be 2. So I'm going to change that to 2. And you get the final thing. So that was considered. Now we have G connecting to the minimum spanning tree by that. So just to make things clear, I'm going to draw red for the edges in the minimum spanning tree. So now you have thing connected by the weights of 3 plus 1 plus 4 plus 2 plus 2 plus 2. So that's your final minimum spanning tree.